Okay, so hopefully we are clear with convolution. If not, don't worry about it. We are going to implement convolution in a practical project. So if we have any doubt, I hope those doubts will be eliminated in upcoming videos. So let's move on to the second component, very important component of CNN, which is going to be pooling. We have two types of pooling, max pooling or average pooling. Mostly max pooling is being used in the industry. So I will explain max pooling to you, and you will automatically get the concept of average pooling as well. But average pooling is rarely being used. So again, in the previous slide, we have the convoluted image. We have the input image, right? The input image is being passed, or you can say being multiplied with the kernel, and we have the output image, right? So we are using the same output over here, where we have the output of convolution as the input of pooling, max pooling, right? Okay, so how this max pooling actually works. So assume that the max pooling matrix size is 2 into 2, where we have 2 rows and 2 columns, right? So we have to project that matrix over here, 2 into 2. So we have to take account of these 2 rows and 2 columns. Now, as the name suggests, it is going to be max pooling. So very simple. Whichever is the maximum value out of these 4s, that is going to be picked. So maximum value is 6, right? So we have picked 6, and 6 is written over here. Then same like the previous example, we will slide this window over here. Now this is our next target. So here, which is the maximum value? Very tough call, right? So 3 is going to be the maximum value. So we will write 3 over here. And what are going to be next 2 values? That is up to you. So try to see what are going to be the upcoming, or you can say the next 2 values. One more thing, you will have to tell yourself, or let's say tell me, what is going to be the size of output matrix in pooling process. We know what is going to be the size of output in convolution process, right? We have a formula for that, which is input image size minus kernel size plus 1. How about the formula in pooling layer? Well, go ahead and try to derive that formula. So here is my output, and I really hope that your output is also matching my output. You might be saying that, hey, if we talk about this part, then yeah, our result is matching. But if we talk about this part, then result is not matching. Yeah, you're right. But here in max pooling, it does not work like that. Once you're done with this part, right, then you'll have to go to this part, right? Since here we do not have any values, so out of 4 and 1, the maximum value is 4, so we will go with 4. So this is how it actually works. Now, the next thing is, how can we implement it in coding? So as usual, first of all, we will implement it by using Numpy, and then we will use what is the PyTorch relevant implementation for it. So first of all, I'm coming back to my original code that I wrote by using Numpy for convolution. And here, just to save some time, I'm pasting the function for max pooling, right? So here we have an image as input. The pool size, or you can see the matrix, in our case, we have 2 into 2, right? So we are calculating the dimensions of output of the pooling layer, right? And the procedure is exactly as same as we had the procedure in the convolution process, right? Moving on. Only the formula is changed, since the output is calculated by image height divided by the pool height, right? And image width divided by the pool width, rather than adding 1 into it, right? So by the way, this is the correction that I told you guys over here, how to calculate the pooling image. The output of pooling layer is calculated by dividing pooling height by dividing image height by pooling height, right? and image width by pooling width respectively. Okay, so now we have the output size. We only have to populate it. So we will first of all get the patch, and then we will get the maximum out of this patch. And what if we have to perform the average pooling? All we have to do is we have to replace this max by average, and that's it, right? And let me run it. Come on, come on, come on. Yeah, it is working. So I'll copy this max pooling function, and let's come over here. So here we have the convoluted image, right? So let's pass this convoluted image to the max pooling, right? So we'll say convoluted image, and the kernel size is going to be, let's say 2 by 2, yeah? And let's store it, and let's call it max, max pooling underscore image, right? And that's it. And let's show it over here. Cool. So here we are previously showing an original image, then the convolved image, and then here we are going to show the max pooled image, right? And we'll have to replace the variable name as well. And here we'll have to add one more dimension. It is not going to be not one more dimension. We have to extend the dimension. So it is going to be 1 by 3 instead of 1 by 2. Previously, we had only 2 images. Now we have 3. So let's run it and see what is the impact that we have. Hi, we do not have anything as an output. Let's see what's wrong. Oh, so here we have made a mistake in indexing. Instead of 1, we have to write 2 and 2. And if I run it now, here we go. So here we have the original image, then we have the convolved image, and then convolved image will be passed to the max pooling layer, and here we have the max pooled image, right? You see the image corner and encrusting features are more sharpened over here. The edges are more sharpened over here, and moreover, if you look at the size of the pooled image, it is almost half of the convolved or the original image. So the number of features, the number of dimensions of our neural network will be significantly reduced in the, you can say, image processing or computer vision kind of tasks. So this is how we can perform max pooling, but we have performed it by using Numpy as usual, and we have to perform it by using PyTorch after it. So I'm leaving it up to you how you can perform it by using PyTorch. Otherwise, I'll do it for you. Okay, so we have seen that how max pooling actually works in CNN by using Numpy. Let's make it work by using PyTorch, because we are going to implement our project by using PyTorch. So we have to learn how we can use PyTorch. So we are using the same old code that we use for convolution using PyTorch, but the only change is, let's call it convolution and pooling. So we are simply going to update the same old code, where here you see we wrote the code for convolution, right? And here we are going to say, let's call it max pooling image, and we'll say nn dot max pooling max pool 2D, and then kernel size is equals to 2, so window is going to be 2 by 2, and stride is going to be again 2, right? So we can make it 0 as well if you want, but I'm going to make it 2 just to reduce the size of a convoluted image further. Cool. So moving on, we have to output this image as well. So we'll simply copy this, paste it over here, and let me copy the name of this convoluted image. We'll paste it over here, converting it to grayscale, and let's call it pooling image, right? And then here is the shape of the pooling image. Let me copy this and paste it over here. We are outputting the shape as well, right? So let me run it. So remember, first of all, we are loading the image, preprocessing, converting it to tensor. Then we are performing convolution on this image. And then we are performing the max pooling on the image. And then we are simply displaying all four images, all three images. But I guess we have an error as usual. So what is going to be that error? Let's see. Let's read the error name. It says max2d is not subscripting. Oh, really? Let's see. Where is max2d? Oh, we did not pass the image. Come on. We had to pass. I mean, on what basis we are going to perform pooling? On what image? So it is going to be conv underscore output, right? Let's run it. Let's see if it works now. No. We had to create a layer first. Come on, guys. So I'm going to copy this over here. So this is max pooling layer. And then, so we're first of all creating a max pooling layer like this. And then we have to call this layer. So we'll say max underscore pooling layer. And we're passing what into it? Yeah, we're passing this convolutional output input, right? And this is going to be our max pooling image. So running it again, crossing the fingers, and yeah, it is working. Cool. So first of all, here we have the input image, 7, looks like same. Then we have this convoluted image. And then we have this max pooled image, right? You can see it over here as well. Moreover, the interesting thing is the sizes. So initially, the image was 225 of size each, height and width. Then 223 after convolution, you know how to calculate it, and then dividing it by 2. So we are left with 111 each for height and width. Why? Because the pooling kernel size was 2 into 2. If pooling kernel size would have been 3 into 3, then we would be dividing this number of the input image to pooling layer by 3. So this is how our max pooling layer actually works. Now let's move on and let me show you this animation one more time that I showed you in very beginning, if you remember. And I really hope that this animation would make a little bit more sense now. So here we have a first convolutional layer, then we have a ReLU function. The output will be sent to another convolutional layer. So here they have, they have joined 2 convolutional layers together, and then they have first max pool layer, right? Same happening again, two convolutional layers, and then they have 1 pooling layer, right? So at first convolutional layer, the input is this image of a truck in 3 channels, right? So input channels are how much? 3. And output channels are how much? 10. So it is creating 10 channels out of 3 channels. So we are inputting 3 inputs, 3 input images, R, G, and B, red, green, and blue. And we are getting output in 10 images, right? So remember the code that we wrote over where? Yes. Here it should be. Yeah, here. You see the input channel is 1, output channel is again 1. So in this case, input channel is 3. Why? Because we have RGB image, colored image, and output channel is 10, right? So we are outputting 10 channels in first convolutional layer. Then we have a ReLU layer, which is neglecting a few inputs. And then we have another convolutional layer, and then we have a max pool layer. If we click on any image, if I click over here, you can see specific calculations as well, and you can see the animation that is showing the convolutional process for a particular output as well, right? So this is how it works. And moreover, if you click on any max pooled image, if I click over here, here you see, this is how the max pooling is actually calculated. So yeah, this is how it works. You can also see the max pool matrix as well. So wherever my max pool window is going, the maximum output is being stored over here. And you can see in max pool, we have, the edges are comparatively more clear than the actual image. And obviously, the dimensions are reduced to half. Initially, the input dimensions were 62. And here you see that after max pooling, the dimensions are 30. And after second max pooling layer, the dimensions are 13, which is roughly 3 times or 6 times lesser than the actual one. Moreover, if we scroll down, we have these kind of animations that I just showed you over there in slow motion over here as well. So you can check it out at your end as well. So that's about it. Regarding the components of CNN. Both components are implemented here, which are max pooling and convolution. And now I think it is a good time to perform something really hands-on. So we are going to implement a practical project where we are going to perform medical image classification by using CNN. You will find the details in next video, and then we will start the implementation.